So in solving some questions on differentiations of inverse trigonometric functions, so you might need some trigonometric transformations and substitutions. So some formulas which you have learned in your trigonometric chapter and inverse trigonometric chapters will be useful in differentiations. So the formulas that are most useful are 1 plus cos x is equal to 2 cos square x by 2, 1 minus cos x is equal to 2 sin square x by 2. 1 plus sin x is sin x by 2 plus cos x by 2 whole square. 1 minus sin x is sin x by 2 minus cos x by 2 whole square. Sin x can be written as 2 tan x by 2 by 1 plus tan square x by 2. Cos x can be written as 1 minus tan square x by 2 by 1 plus tan square x by 2. Similarly, tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. Tan inverse x minus tan inverse y is tan inverse of x minus y by 1 plus xy. And sometimes if you have some functions inside sine inverse, cos inverse and tan inverse, and you have to differentiate them. First, if you look at some expressions like this, do the substitutions and simplify the question. So root of a square minus x square, x is equal to a sin theta plus a cos theta. X equal to either a sin theta or a cos theta. If you have root of a square plus x square, so x is equal to a tan theta or a cot theta. Root of x square minus a square, x equal to a secant theta or a cosecant theta. And root of a plus x or root of a minus x if you have expressions like this. So you put x is equal to a cos 2 theta. So if you have both of these expressions in a single question, you can think of x is equal to a cos 2 theta. So your aim in substitution will be to remove these square roots. So let us look at some sample questions where these trigonometric transformations and substitutions will be useful in differentiation of inverse functions.